Hey everybody, this is Dr. A, and in this video we are going to be exploring a second example of linear interpolation. You can check out my other video that gives you a little bit of background of what linear interpolation is with the first example that I have. So this is the second example that we're going to be going through. So as always, you want to write all of this down. Don't just think you can watch the video and fully understand it, especially if you're new to this. Write this down and practice. So let's start with our given information. Under given, we want to determine the value for D using linear interpolation. Spell that correctly. Interpolation. Okay, so we're going to be given a table here. And the top row is going to be, designated by the letter A. So, and then the bottom row is going to be designated by the letter B. And so in row A, we're going to have a known value of 3. We have an unknown value of D, and then back to a known value of -8. And then row B, we have known values of 5, 7, and 9, okay? And so just by looking at this given information, what are our known points through which we're going to establish a linear relationship? Well, the known points are going to be a point -3, 5 and -8, 9, okay? So let's go ahead and start with our solution, all right? So known points are -3, 5 and -8, 9. Now here's something interesting. Because this is in tabular form and we're just developing a linear relationship, we could actually flip-flop each of these 2 points and we would get the same answer. So watch this. I'm going to say known points are -3, 5 and -8, 9. That's fine. I'm going to put in purple here. I'm going to say, or we could think of this as known points of 5, -3 and 9, -8. Okay, it doesn't really matter how you think of these known points, as long as you know which 2 values correspond to one another. We know that the -3 and the 5 form one ordered pair, and we know that the -8 and the 9 form a different ordered pair, okay? And then, of course, the value of D and 7 form the intermediate ordered pair in which we need to discover what D is. But which one you label as the independent variable and dependent variable doesn't really matter in terms of the process and the mechanics of going through linear interpolation. Now, of course, if you have an applied problem and a problem is telling you what the independent variable value is and what the dependent variable data set is, for example, then you need to stick with what the given problem statement is telling you for your particular problem. But in this example, nothing is indicating what is the independent variable values and what are the dependent variable values. So again, in terms of executing the linear interpolation process, all you need to know is what 2 data points are corresponding with one another, which points are forming the ordered pairs, okay? So I'm going to, look at this as -3, 5 and -8, 9, but I encourage you on your own, just reverse each of these numbers. Now, you got to reverse them both. Notice I said 5, 3 and 9, -8. You have to reverse both of them, but you could do it that way and you'll get the same value that I'm going to get with D here in just a second. So as I mentioned in my other video, what I like to do is I like to redraw the data table, and I'll put my ordered pairs here. And then I'm looking for this value of D that corresponds with the number 7. And I like to draw these arrows to help me out. And as I mentioned in my other video, how you draw your arrows, you have some options here. you just have to be consistent. You have to subtract and divide values in the same pattern on the left side of the equation as you do on the right side of the equation that you're going to build. So here's what I'm going to do. I'm going to say -3 minus -8 minus -8 divided by -3 minus d. And that's going to be my left side of the equation. I'm going to put an equal sign, and I'm going to say 5 minus 9 in the numerator divided by 5 minus 7 in the denominator. Now again, notice that I subtracted and divided values in the same pattern on the left side of the equation as I did the right side of the equation. So the left side of my equation represents what's happening with values for A, and the right side of my equation represents what happens with values for B, okay? And again, I subtracted and divided in the same pattern on the left and the right side. So now it's basic arithmetic or basic algebra. So the left side of the equation, you end up with 5 divided by -3 minus d equals -4 divided by -2. And then, of course, this kind of reduces down some. You can say 5 over -3 minus d. I'm going to do a little bit of algebra, intermediate algebra steps here to help everyone out. So that equals 2. And then we can do some cross multiplication, and we can see that we end up with -3 minus d equals 5 halves. And then we can, again, do a little bit of rearranging and solve for d. Put a comma here, and I'm going to say d equals -11 over 2. And that's our answer. Now, in decimal form, we would say this equals, d equals -5.5, okay? So you can always go back and ask yourself, does this make sense? Do these values make sense? Well, looking back at your data, I would say, yeah, it certainly makes sense, because think about what you've done here. You've built a linear relationship between the ordered pair -3, 5 and -8, 9, okay? And the value that you know that's between 5 and 9 is this number 7, okay? So the value of d that's corresponding with the 7 should be somewhere in between -3 and -8, just like the 7 is in between the 5 and the 9. And so you can always do a mental check yourself and ask yourself, does it make sense? Does the value I got, -5.5, make sense? I would say it does make sense, because if you clearly look at it, it's pretty much right in between the 3 and the 8, just like the 7 is right in between the 5 and the 9. So that's going to conclude this second example video on linear interpolation.